Okay, so we're going to solve systems with matrices. My first example is not really solving a system. So some people are having small issues with this.
Why does it say not unique?
There's not a unique method to write in row echelon form. Like, there are multiple ways to get this done. What I want you to do, and notice this is not an augmented matrix. This is just a matrix, 3 by 4 order, and it just has entries. You can, like, when we actually solve the system of equations, we need an augmented matrix. Okay? This is not that, so we're not actually solving a system, but other matrices can also be written in row echelon form or reduced row echelon form. Like, that works for all matrices, whether they represent systems in augmented matrices or not. So all I'm asking you here to do is think about some row operations that you might perform so that this looks like row echelon form. So this is basically number 41 and 42, but we're not telling you what to do. Okay, so remember some things about row echelon form. If you have any rows of zeros, they're all at the bottom of your matrix. You want every row to have the first non-zero term be a leading 1. And then you want your leading ones at the top rows of your matrix to be furthest to the left. And then for each successive row, that leading 1 moves over and is closer to the right side of the matrix. Okay, so those are some of the characteristics that you're looking for. I'm going to give you about 5 minutes in your small groups to have some conversations about what you might do to make that look like row echelon form. Now there's got to be a little bit of give and take in your group, because Manny might have one idea and then Jennifer has another idea. You can talk about each idea and which way you want to go with it. I would be thinking about, like, could you justify to your group so that your group could justify to us why you would perform such an operation, and think about, like, there's an end goal, right? The leading ones and the fact that the leading ones move over. You need those zeros at the front. So really put that at the forefront of your goal for writing it in row echelon form.
I'm pretty sure, but you're supposed to use columns.
No, you don't need the columns. This is not solving a system. This is just a matrix, and we can write any matrix in row echelon form. So I want you to talk in your small groups for about 5 minutes about getting it in row echelon form. And remember how in number 41 and 42, they gave you, like, things like take 2 times row 1 plus row 2. I would also, with your group, kind of write those things out so you could describe to us, or you could see if you did any of the same things.
Since it's not solving an equation, could we change it so that it was like, for the first row, could it be 1, negative 1, 2, 3, or
No.
is that not
You should not interchange columns. You may only interchange rows. That's an elementary row operation. Okay? Have that conversation now with your rows. Groups. And I'm all matrixed out. There are multiple ways to do it. We can get to the same work or same answer through different work. But I like to think there is a way to work a little bit smarter and not harder when writing in row echelon form. So here's the first thing I would do when I look at this matrix. Check my rows. Are any of my rows currently good to go for row echelon form? The first row. Okay, so hopefully you kind of do a little survey of your matrix. This row has a leading 1. Furthest to the left, it's already at the top of the matrix, so it's right where it should be. That means I'm going to make a mental note to myself, don't do anything to row 1. All of my changes will then happen to row 2 and row 3. Can you change row 1? Sure, but I'm thinking then I might be working a little bit harder than I need to because I'm moving things around that are already good to go. So that means I'm going to write a new matrix. I'm going to keep row 1 as is, make no changes. And so I've got the decision of, am I going to change row 2 or row 3? And I will tell you this. When I write in row echelon form, I try, if possible, to go down my matrix. So the next line that I'm really going to focus on is line 2. And I want to do things to row 2 so that row 2 looks more like row echelon form. So some issues with row 2. It doesn't have a leading 1 as it sits. And because I already have a leading 1 in the first row, I need my second row's leading 1 to be moved at least 1 to the right. Right? It needs to be more to the right than its preceding row. So I'm thinking about, I'd really like to have a 0 as my first entry in row 2. So I'm focused on row 2. I'm going to copy my row 3 because I'm not changing row 3 right now. I'm focused on row 2. How can I use either row 1 or row 3 to get me a 0 in the first column of row 2? Lily?
You could multiply row 1 by -3, and then you can add that to row 2.
-3 times row 1 plus row 2. If you use this method and you get a leading 1 in one of your equations, you're going to find that leading 1 to be super helpful in canceling out and getting those zeros that you need in your other rows, because then you just have to multiply it by the opposite, and it will cancel into a 0. So we're going to multiply by the opposite of what that first term is, which is -3. 1 times -3 plus 3 is 0. 2 times -3 is -6, plus 7 is 1. -1 times -3 is +3, plus -5 is -2. And then -3 times 3 is -9, plus 14 is 5. And I saw a lot of groups get this second line. Okay, so that's excellent. And, you know, when I get that second line, I also make a little note to myself. Not only did I get a 0, but I also got a leading 1, which is what I want. So as I look at my matrix now, row 1 is good, row 2 is good. I'm now going to put all my focus on row 3. Okay. So I'm going to copy the matrix again. Just row 1 and row 2, those are good. I don't want to change them anymore because as they sit, they're in row echelon form. I have got to think about how I can change row 3 so that I'm doing the same things I was doing in row 2. I need to get a leading 1. I also need these first 2 column entries to be zeros. And so I would start with my first column. How can you get a 0? Jennifer.
Take row 1 times 2.
Row 1 times 2, add it to row 3. Okay, excellent. So 2 times row 1 plus row 3. That would be 2 plus -2, which is 0. 4 plus -1, which is 3. -2 plus -3. Am I on the right one? -5. And 6 plus 8 is 14. So again, I'm happy because I got that 0. I always have a goal in mind. I'm getting a 1 or I'm getting a 0. Okay. Well, I'm getting closer, but I'm not quite there. Are you going to tell me the next step? Anybody else know what I could do for the next step? Jennifer gave me one. I need another 0 in that row. What could I do now? Ethan?
Wait, no, that wouldn't work. I was going to say 3R1 plus 2R3, but that wouldn't work because that would give you 3, 6. But that cancels out that 1 because that doesn't work.
Yeah. Remember, the ones with the leading ones are going to be helpful. We just want to cancel out +3. So look at this row right above it. Multiply it by -3. That leading 1 is super helpful. It will let you cancel out that issue. And since I'm working down my matrix, I already have a 0 right in that first spot. It's not going to affect my new 0 in the other row. So we would do something like -3 times row 2 plus row 3. So that would be -3 times 0 plus 0 is 0. -3 times 1 is -3 plus 3 is 0. -3 times -2 is 6 minus 5, 1. And negative 3 times 5 is negative 15 plus 14 is negative 1. So that got me a leading one already, right? Pretty good. Row echelon form, done. So there are some things, it's not like just choose random things, but really choose with a purpose. And I would really think about my purpose as I want leading ones, and I also am going to need some of those zeros so my leading ones move over. If you already have zeros, like on this green line, and like Ethan said, if you go back to row 1 and you start adding those 2 rows, then your 0 goes away. So you will have effectively undone that 0 entry that you got. So you need to choose the row above it that already has the 0. Okay, so there is some strategy there. Okay, so now we're going to put this to use with the natural system. On your quiz, problem set, etc., I will give you a linear system. This one is in 3 variables. Looks like x plus 3y plus 4z equals 7. 2x plus 7y plus 5z equals 10. 3x plus 10y plus 4z equals 27. Solve using matrices. Now, in this chapter, I want you to use matrices. It's a skill that you're going to work on. Could you solve it algebraically? Sure, in a worst case scenario, but you're going to attempt to do it with matrices. So, first step to this, take your system, write an augmented matrix. Okay, so rule number 1, write an augmented matrix. Yes?
Is there a specific benefit to solving algebraically just with rows, or is it just another way?
I think it's just another way to solve. Some people may argue it's the benefit would be its organization. You know, whereas like when you're thinking back to like that 3 variable system and I handed back your test yesterday and I said like, I tried to follow where you were going. But you eliminated these 2 and then you eliminate it over here and then you put it over here. Whereas like in a matrix, you'd just be like going step by step for all the matrices. So I don't know that there's like a specific other benefit other than it's a different way and perhaps the organization. Okay, after you write the augmented matrix, write it in row echelon form. So now you're doing all the work you did in the previous problem. You have some insight into like how I think about a problem. Are any of your rows good to go? Row 1. What row are we going to focus on next? The second row. So I'm going to write the first and the third as is. And what might you do to the second row, Dylan?
You say -2 times R1 plus R2.
Yes. You're going to use that row, that first row, like Dylan does, row 1, that has the leading 1, because you're just multiply by the opposite. -2. So -2 plus 2 is 0. -2 times 3 is -6 plus 7 is 1. -2 times 4 is -8 plus 5, -3. And -2 times 7 is -14 plus 10 is -4. Make sure you check my math today. Okay, so row 1 and row 2 are good. Now we're going to focus on row 3. Okay, so I'm going to copy row 1 and row 2. What is something you might do to row 3 to get us in row echelon form?
-3R1 plus R3, and if the math checks out this time, that actually cancels out both the first 2. So I don't know if the next one's going to be 1.
Okay, so -3 times row 1 plus row 3. Again, we're using the leading 1 from the first equation to get that first column to be a 0, which is what we're looking for. So -3 times 1 is -3 plus 3 is 0. Negative 3 times 3 is negative 9, plus 10 is 1. Negative 3 times 4 is negative 12, plus 4 is negative 8, and negative 3 times 7, negative 21, plus 27 is 6. But that's actually looking pretty good, right? Other than the fact that we've got a leading 1, but it needs to kind of be moved over. So we're not done there. We're still going to have to change row 3. We need a 0 right there. How can we get a 0? Negate the second line, so second row, negative 1 times row 2, and then add it to row 3. Yeah. Basically like subtract the rows. Okay. So that would be 0. Then negative 1 plus 1 would be 0. This would be positive 3 plus negative 8. So negative 5. And then positive 4 plus 6 is 10. So that did get us our 0, but then it took away the leading 1. But now again, I don't have to go back to any of my other equations because they're set. They're ready for row echelon. I just have to focus on that last one. How could I change it
Negative,
so that I get a positive 1?
negative 1/5 or 3.
Multiply by a scalar, a number, right? Multiply it by the reciprocal of negative 5, which would be negative 1/5. That will turn it into 1. Okay, so you're allowed to multiply a row by a single value. Okay, so I copy row 1, I copy row 2, and then we're going to do negative 1/5 row 1, or sorry, row 3. Okay. Now, I will say this. If I'm working to get in row echelon form, I try to do that multiplication at the very end. The stuff that I do above, I might multiply and add things, but I try not to just multiply by a scalar too early. Okay. Sometimes you might come up with lots of fractions, and while you could solve it that way, it's probably not the nicest way to solve it. So this gives me 0, 0, 1, and negative 2. Okay. Is that the answer to the question that's being asked of us? Solve the system. Not quite. What should you do to continue solving the system? Ethan?
Now that we have this form, we can take the last equation, which is if you go up, basically that tells us that z is equal to negative 2, and then from there we can plug z back into the next equation up. We know that negative 3 times negative 2 would be 6.
Okay, so good.
Yeah.
Back substitution, right? You're just going to say z is now negative 2. That's the benefit of row echelon form, is that you immediately have one of your variables. Okay? So you know z is negative 2. Back sub in, because it's in row echelon form, the next equation will only have y and z. Y plus 6 equals negative 4. Subtract 6 from both sides, so you're going to have negative 2.
10.
I wrote 10, didn't I? Negative 10. Okay. And then back sub into that first equation, x minus 30 minus 8 equals 7. So add 38 to both sides. X is 45. So just like in your chapter 7 test, your answers to a 3-variable system should be in order triple. That should be true if you're solving a 3-variable system with matrices. Okay, cool?
Like on the test, it was like find how much, like how many boxes of breakfast bars or like granola bars. Could you just like label the number and not put it in the like parentheses? Like you say like if they only ask about 2, could you say you need like this many breakfast bars or this many granola bars? We're just talking about like the maximum.
If it was a word problem,
Yeah.
should I have labels? Is that what you're asking me?
Well, like, do we have to put it in that if it's a word problem?
No, if it's a word problem, you would make statements like, 4 pounds this, 20 bars that. Yes, you would label things and you could write out your answer. Yeah. Okay, I get it now. Okay, now, if you have a graphing calculator, can you please get it out? prepared for Monday, I'm gonna come down the road. Let me know if you don't have a graphing calculator.
I do. I have one at home. I don't keep forgetting to bring it.
Well, you have one at home. Will you bring it?
Yes, I plan to bring it tomorrow.
Okay. Yes. Gosh, they made those graphing calculators so small they look like regular calculators.
This looks like a regular calculator.
Yeah, it's all like, especially Jones because it's blue. I picked this exact for a little one.
Calculators came out in like 2007.
This not this one.
T84.
Okay, don't say stuff about her calculator.
Well, I'm just saying that I
It's a
know,
silver fox, okay?
I know that the TI-83 Plus came out in the year 1996.
That's what I have.
So thusly, why would
My brother.
a TI-84 come out?
Because he actually got a new one.
Because
I thought
the same reason that they made the iPhone 7, or the iPhone 6, the iPhone 6s, and then the iPhone 6 SE, which was in reality just a retest.
Okay, if you have a Casio, I apologize. I do not know how to use the Casio. It would be like if you would put an Apple computer in front of me. Don't know what those little red, green, and yellow light things are at the top of every window. You know what I'm talking about?
Minimize, resize, close.
I'm scared to touch all of them because I don't know what they do.
It's the same thing as
Don't touch the red one unless you want to get rid of the window.
My note is, let's see, I know, Katie, you've got a Casio. Anybody else in here got a Casio one? Okay, so you're a loner in this class. Bummer. I usually tell like who is your Casio friend, but I do have some people in other classes, and so if you know anybody who uses a Casio, you can talk to them. The best thing I could say is Google it, and you can do that right now on your phone while I'm doing it with my TI people. Because if you ask me for help after school today, I will do that. I will Google it, and I will tell you what Google tells us to do. And we can figure it out together if we need to, but you just always Google. Okay, my TI people, to get to your matrix menu, you type second, and then it looks like X to the negative one, but that really, in math terms, is an inverse. So I call it like second inverse. And it's right underneath the math button. Okay, so you type second. Ooh, I gotta turn on my calculator. I'm gonna spoil everything. Second x to the negative.
It's like a vertical calculator.
Oh, yes.
I know. I thought it was just like her.
Okay, my apologies. When you get to the matrix menu, oh yeah, and I don't know how to work other versions,
Oh, that's good.
but I might be able to figure it out. But you would do the same thing, like I'm just gonna tell everybody else and I'll come around and see how you guys are doing. But like you could also have out your phone and be Googling things. And I will also assist you in any way that I can, but it will take me time. When you type second x to negative 1, you get to this menu that has 3 topics. Names, math, edit. And like names is just where when you finally do everything, like put in your matrices and you decide which operation you're going to do with your matrices. Names is just where you go to say, this matrix is the matrix I want to work with. Okay, so names we don't really use until the very end. You're going to scroll over to edit, and yours are probably empty. I usually just work with like A, B, and C and overwrite them as needed. You're going to click on matrix A, and it will ask you immediately in matrix A what order it should be. So you're going to type, because this is a 4x4, you're going to type 4x4. And then it will give you 4 rows and 4 columns, and then you just input all the data. So you're just a little data entry person right now.
This makes me excited. I'm afraid I'm gonna mess.
Oh, shoot. I messed it up.
Oh, it's error.
So this is what we're spending $100 on.
all of them.
Mine's gonna look like turds.
What?
I don't know.
The ones that are.
Oh, it was.
It's 89.
Not my
Oh,
I was
I got my one.
This makes me.
I need to get my own copy.
Of what?
The font on this is so big though, like I'm already
I like
I need to know that.
Legend. Wow.
Hey Lexi, you want to hear a fun fact about your calculator? If you press apps 7, you have a complete periodic table.
If I press what?
Apps 7, you have a complete periodic table.
Apps on 7.
Are you finding anything, Katie?
Kind of.
Oh yeah. Did you click on that?
What
does that mean? Usually.
I don't know if it means, I don't know if it means like, yeah, you have that. Oh, do you have a matrix? Yeah,
What does it say? Choose run matrix.
Mine's like the right version.
And
Oh,
series
got
of
it,
matrix that
got
are
it.
equal to everything.
The last one.
Keep Googling. Okay. Now, you've put in all your data. So this is the weird thing about the matrix menu. To do anything with your matrix, you have to get out of this. So to get out of the matrix, just hit second mode. That's how you escape.
Oh my goodness.
Stop it!
Does it say? It's doing
Yeah, it's in there.
It's doing.
If you typed enter, it's in there. If you're still typing, you're typing this matrix, right?
I don't know. I hope I can.
Those were the numbers that we were typing in. Okay, now to actually calculate things, because my example says write it in RREF, which is reduced row echelon form, then you have to go back to the matrix menu, so second inverse. And this time, math is what you want. It will tell you like all the things you can do. We'll eventually use this determinant, but you want to scroll down or scroll up. A is reduced echelon form, A is row echelon form, B is reduced row echelon form. Since I asked for reduced row echelon form, hit enter for reduced row echelon form. Okay, I'll come help you in just a second. And then do second matrix and choose A under names. And then hit enter and it will do reduced row echelon form.
Oh my gosh.
You have to do both. Second.
That's so.
Oh, yeah.
Okay, now hit enter.
Oh, yeah.
I'm so cool.
Oh, I did it.
Yeah, yeah.
And then you can copy out your reduced row echelon form.
Oh, you're right there. Like,
Oh.
When you reduce row echelon form, look the same for any.
So for a basic matrix, it should be of this form. I mean, I suppose technically you could have
Like a 4x4 would look that way.
you could have a row of zeros. But yeah, you kind of know what reduced row echelon form is going to look like because your ones have to be preceded and followed by zeros, correct?
Yes.
Okay, but the key thing here to note is this is just like that first example I did. It's a regular matrix. Next slide, we're going to do an augmented matrix to solve the system. Okay, so are we okay with reduced row echelon form?
see.
Okay, now I'm going to go to the next slide. And we would like to solve this system using our calculator. So you're going to go to your matrix menu. And instead of, you can either type over A or you can do B. It doesn't matter. I did B. This time your dimensions, I always do that. Oh my. You gotta go over to edit, don't you? I'm terrible. I've done this 3 times in a row now and I always miss that. Go over to edit. You're going to choose A or B, doesn't matter, but this time your order should be 4 by 5 because it's not going to be that square matrix anymore. You've got the what it's equal to side of things. So you go to, I'm doing B, you can do it in A or B, and then you type in your 4 by 5.
I mean, like this. Oh, yeah. What happens when you click F4?
Are they all?
4 plus.
That's plus.
Alright.
You have, what do you have?
2,
Yeah, I have to.
5,
all the
-3, -1 again,
Oh, darn it.
4,
Okay, so you could.
Oh,
12,
Yeah.
what?
2,
I'll write this down.
1.
Second on tomorrow.
So now here, next ones are 11,
Did it?
Yes.
30,
And then if you figure it out, you don't
-5,
have to come. And if you want to come in.
and -9.
I'll see if I can figure it out tonight.
Do you fill out your instructions?
And like also, Katie, we might also be able to go like search, just Google it, and there might also be a YouTube video
Yeah, but how-
where someone like works it out, you know.
Wait a minute.
Okay, then how do you get that?
Second mode. And then.
How do you put it in the like little sign or whatever?
You don't. It'll just be. So Sammy just asked a question about my matrix. She asked, how would I put in that like colon for my augmented matrix? I don't. So it's like 4, 11. You're just typing in the 4x5 matrix. You don't really need those colons for your calculator to do the reduced row echelon form. Okay. So once I type those in, then I go back and I do the same things I did before. I'm going to get out of here. I'm going to go to my matrix menu. I'm going to choose reduced row echelon form. And then I'm going to go choose B. You might be choosing A.
So weird.
Okay, do you see the 4x4 is the same thing we got on the previous slide?
Yep.
The last column is your answers. X is -1, Y is 1, Z is 3, W is 1.
That's neat.
It is neat. So I have a solution.
Now we have a point for dimensional space.
Okay, now if you're having trouble with your calculator, please come in and see me.